Hello everyone! Today in this video, we will see how to control a step motor with a Modicon TM221 PLC. We will use the free version of EcoStruxure Machine Expert Basic to program the PLC. We will use the TB6600 4A DC 924-volt driver to supply the stepper motor. And the motor which we are going to use is Stepper Online Nema 17 Bipolar 42 NCM. We can find this in 3D printers or in a milling machine.
Start Machine Expert and make the hardware configuration. Here we will use the PLC model with 16 transistor outputs, which are fast outputs. On the right-hand side in the library, select the TM221CE16T model. Drag and drop it onto the current PLC to replace the model. Click Yes in the pop-up window to confirm the replacement of the model. On the left-hand side are the properties of the current hardware model. Go to Properties, then select Pulse Generators to configure a pulse generator for the step motor. In the middle window, under the PLC model, you will see the properties of the pulse generators. Click on the 3 dots of the first pulse generator for configuration. A new window will pop up. The window is a pulse generator assistant. Under Type of Pulse Generator, click the arrow beside Not Configured to select a type of generator. Select the last element in the drop-down list, Frequency Generator. In the assistant, you will see that the default output is Q0.0. Click Apply to validate the frequency generator. Now go to Programming Mode to create the logic for the step motor control program. In the top library, under the pulse symbol, select the frequency generator configured previously. Now we will set the inputs and outputs of our frequency generator. Set the physical output Q0.1 as the frequency info output. For the enable input, place in series 1 NO contact and 1 NC contact to enable and disable the frequency block. Add 1 NO contact for the synchronization input. This will be the physical output of the frequency generator info, Q0.1. Add a physical output Q0.2 for the busy output of the frequency block. While the block is running, the output is true. Add a physical output Q0.4 for the error output of the block. When this turns true, it means the block is not working as desired. These block outputs are only for information, to let the user know in which state the frequency block is. Add a new rung to build more logic. Add a fast counter to define how many pulses the generator must generate. Let's configure the fast counter. Name it FC0 as a typical name for this function, and its address will be sent FC0. Go again to the Configuration tab. We have to configure our function and check its default input, physical input. Click on the Configuration tab and select Fast Counters on the left-hand side of the window. Set the type of counter as an up counter and select FC0 in the first counter properties. You can see its input is I0.2. Add a no contact to the ion input of the FC0 block and another NO contact to the reset input. Add a new rung for receiving data from a remote device through the Modbus network. In this new rung, add a comparison block and check if the value of the fast counter FC0 has reached the value of the exchanged word MW10. Here, to access the value of the fast counter, we have to write sent FC0.v. The V means value. Set the result the comparison in memory M44. In a new line, add a short block as input and an expression block as output. Here, input and output mean only left and right. In the expression block, we will assign the frequency value of the frequency generator. To access or assign the frequency value, write frqgen.frq. Then we will take the value of variable MW50 and use it as the frequency value. The dword function allows us to convert the value of MW50 to a double word. Here we go, we were almost done. Go to the Commissioning tab to establish communication with the PLC. If your PLC is connected to the same network as your computer, you will see the IP address of your PLC appear under Ethernet devices. If you are connected to your PLC with a USB cable, you will also see it appear under local devices. Here we will use the Ethernet network. Select the IP address of your PLC and click Login. It should take only a few seconds. Then it will establish communication with the PLC.
Now, in order to set the number of pulses, stop the frequency generator when the desired number of pulses is reached, and reset the fast counter. Add this middle logic to the program. So how does this work? You have to first set the frequency of the frequency generator and set the number of pulses that the fast counter must reach. When the fast counter reaches the specified number of pulses, I remind you that the input of the fast counter is the physical input I0.0, which we will wire later to the physical output of the frequency generator as pulse feedback. The bit M44 will be activated and disable stop the frequency generator. For the wiring, here we have the PLC supplied with 24 volts, the stepper motor supplied with 12 volts, and the stepper motor controller supplied with 12 volts too. The pulse input signal of the controller is expecting 5 volts. Here, since the controller pulse input expects a 5-volt signal, and the PLC fast output Q0.0 produces a 24-volt signal, we added a simple electronic circuit using an NPN transistor supplied with 5 volts and driven by the PLC pulse output. Not only that, but it also plays the role of an inverter to make the signal compatible between the PLC and the logic chosen for the controller. As we made the enable pin connected to 0 volts, the direction pin connected to 0 volts, and the pulse negative pin connected to 0 volt. For the PLC pulse feedback for the fast counter, wire the fast output Q0 to the input I0.2. Let's now speed up the video for the wiring of all the components in the project.
For remote control with a smartphone via Modbus TCP over a wireless network, we will use the Android app Modbus TCP IP Mobile. The app is available on Google Play for free. Install the app and open it. When your mobile device and the PLC are connected to the same network, you can establish communication via Modbus between your mobile and the PLC. When the app is opened, you will see on the welcome screen a field for the IP address. Enter the IP address of your PLC in this field. Keep the port number as 5002, and for the slave number, use the slave number of your PLC, although this is optional. Click on the Connect button to establish communication with the PLC. When there is no error, the wireless symbol will animate, which means that we are connected. In the app, at the top right, click on the menu and go to the tab Read Write Coil to control the frequency generator, run stop. Set the address of the coil to 9 as already programmed in the PLC to enable or stop the frequency generator. By clicking on the Write Coil button, the coil will switch its state with every click and write this command to the PLC. So here, the motor will make a defined number of steps and then stop. In the program, every time the fast counter reaches the specified number of steps, it will stop the pulse generator and reset its own value to 0. Then, when the motor has stopped, and you click the button again, the motor will make the same number of steps again and stop once more. Let's change the frequency, which means the speed of the step motor. Go to the menu at the top left of the screen and select the Write Register tab. Inside, set the address of the register to 50, and set the frequency value to 30 in the value field. Click the Write button to send the value to the PLC. To enable the frequency generator again, set bit 9 to 1 and send it to the PLC. The motor will run again with the new speed. Let's try it slower. Choose 12 for the frequency in register address 50. The motor will run even slower, and this time we can clearly recognize the steps. You can also go faster. Choose, for example, 2000 for the frequency. The motor will rotate like a DC motor. Let's try a high frequency and check if our system will support it. Choose this time 30,000 for the frequency and activate the frequency generator. Okay, it seems that the system does not support this frequency. Anyway, for the PLC, the maximum frequency output can go up to 100 kilohertz. I think we are stuck here. I will reboot the controller to make it work again. Let's now try again, 5 kilohertz. It's working again. And what about a lower frequency? Set 17 hertz. Here we go. It is working as well. Et voila! This is all for this video. That's it for this tutorial on how to control a stepper motor using a PLC. I hope the steps were clear and easy to follow, and that you now have a better understanding of how PLCs can be used for precise motor control applications. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell so you don't miss future tutorials. Feel free to leave any questions or suggestions in the comments. I always try to respond and help where I can. Thanks for watching, and I'll see you in the next video.